Hi. So yes, I'm Katie Peak. I have a robot. And I use it to wheel around the office of popular science is the short answer, but I'm happy to tell you more. Yes, I'm the information graphics editor at Popular Science. Popular Science has been around since 1872. Our first issue looked a little something like that. Not a single infographic in sight. But this is an issue from 1930. By then we had color and pictures in the magazine. And here's a graphic that appeared in that issue. My archive search has not been exhaustive, I'll admit, but this is so far the earliest infographic I've found in our archives. It is a timeline horizontally, and the vertical scale is awesomeness, I'm pretty sure. Here's what the author says. He says, the vertical, sorry, it's a little small on my screen. The vertical measurement of the graphs represents, on an arbitrary scale, the comparative achievements of the races of mankind in their struggle toward an ideal state. Did I mention that this was the 1930 issue? The age sort of shows, I think. And another one of my favorite things about this chart is if you look at the timeline across the bottom, which I see the bottom's going to be a little hard to see from the sides, but the most modern human over on the far side is all hunched over his machine, not unlike the caveman at the very beginning. So apparently the ideal state of mankind is stooped. Anyway, I poke fun, but it's a graphic that accomplishes a lot of what I hope many of my graphics accomplish, which is that it shows a very broad trend of increasing awesomeness with time, but it also gives a lot of detail and depth for people to sort of bring their own background and understanding and knowledge and dig into the details and maybe take away something new and learn something. So fast forward to today, we try to be a little more quantitative in our information graphics at Popular Science. These are some that we've done recently. I'm going to talk about 4 of them in a little bit of depth today to share the stories of how they came to be from an editor's / designer perspective. My official title of my talk is Information Graphics at Popular Science, but in my head I've been calling it Visual Storytelling with a Graphics Desk of One, which I freely admit is the loneliest title ever. But at PopSci, the way it works, just for a little bit of context, is that we have an editorial team and an art team, and my job is to sit squarely between the two. I actually started out on the editorial side of things, and then I spent a year or so as a graphic designer at the magazine, on the art side of things, and I've since sort of settled back into this middle way where I'm finding stories and then telling them visually through data. And as Ellie mentioned, the reason that I love doing this at Popular Science in particular is that my original training is as a scientist. And so the recovering astrophysicist in me really loves being able to tell science stories visually. So this is a graphic that we ran this past year in our June issue. It was called Heat Map in print, but I've been calling it War and Peace in my head because it's a map showing water conflicts throughout the world. And what I really like about it is that the areas that you see, instead of being the usual countries, are international river basins. And we're showing sort of the conflicts that have arisen over water in each of those basins. And the underlying database was great because it graded all of the conflicts on a scale from the most hostile, which is -7, which means war breaks out over water, all the way to +7. And +7 is the opposite of war, which is not peace, but rather voluntary unification into a single country, which has never actually happened. But I just love the idea that 2 countries love their shared river so much that they basically decide to get married over it. Anyway, Pitch Interactive made this graphic for us, I should mention. And the data underneath it came from a database that was compiled by a group of geographers at Oregon State University, and it actually took them a decade to do it. And I'm showing it as an example because at such a small publication, we have to rely on data that other people put together to get this sort of like really rich data underneath the graphics that we do many times. And one choice we had to make with this graphic was how far back in the database to go. So here's a chart that came from the researchers originally, showing just the number of events that happened in the database. The whole database goes back to 1948. But just looking at the numbers, it was clear that reporting was not quite as good in those early years, and that it's not that we've been fighting over water more recently. It's just that there's been less sort of awareness and coverage of it, at least in the database that they compiled. So I worked with the researchers to sort of understand the data better, to be able to make the cut and say, okay, we're just going to show the events from 1990 onward in this map. So this map is actually just 1990 forward. And that's a very simple cut to make, but it was a lot easier to do because I was in dialogue with the people who made the data, who know it best in making those decisions. The next chart is one called How the World Wastes Food. And the data for this one came from a report published by the United Nations Food and Agriculture Organization. So they basically did a global accounting of where food is lost worldwide. And the report had lots of data. It showed the 7 types of food that are horizontally in my graphic there, and then vertically we see 5 stages of processing from farming through getting it to the grocery store and food waste after at the end of the meal. But the original data also included all of those numbers for 7 different world regions, which was just too much for the sort of Sankey style diagram that I wanted to do. And that much granularity really would have buried the main takeaway, which is summarized in these numbers along the bottom, which the point is that for some types of food, we're losing nearly half of what we grow. So in the original data, it was all listed in like relative percentages, and so I couldn't actually like lump things together myself. So again, I had to go back to the original researchers and get a different form of the data that I could then manipulate to be something that I could use to make a much simpler graphic that shows just industrialized nations are on the left of each stripe and developing nations on the right, and that just simplified things enough that the takeaway is really clear, but there's still some depth if people want to dig in and spend some time with the magazine. All of these are things that we've done for print, just in case that wasn't clear. So people are sitting with the magazine and diving into these in print. So that's 2 examples of where I'm working with the researchers who made the data to get it into a form that I can use. We also do graphics where we do some amount of original analysis, but usually for that, I'm collaborating with studios that have the bandwidth to do it. So this is one that, an example of that. It's called The Lifecycle of Ideas. Giorgio Lupi actually showed this last year at Tapestry when it was finished, but we hadn't actually published it yet. So it ran in our May issue. And here, we took a lot of raw data from the Thomson Reuters Web of Science database about academic citations, how often scientific papers cite one another. And the question that we were trying to explore was how long does a scientific theory sort of live in the zeitgeist and is discussed among scientists before it either is accepted, is canon, and we don't have to talk about it anymore, or falls out of favor. So Georgia and her team at Accurat did most of the heavy lifting on the analysis for this one. And all the trends that we uncovered were sort of new trends to us, and so we filed it under the story type hypothesis. But even with that heading, I still worked with outside experts to make sure that the trends that we're showing are reasonable and accurate, at least as well as we can determine. And so actually for this one, I was working with an information scientist at the University of Washington who was very helpful. And he had a great little insight that made it onto the page. So if you zoom in on these little bubbles, each one represents a scientific field. And the music notes are the top most cited papers in that field. And the dots over the notes are the number of authors on that field, and the arcs connect the same author if he or she appears on multiple papers. So in talking with my information scientist expert, he said, I'll bet you've got some Nobel Prize winners among those arcs. And so I checked, and he was right. Of the 30 arcs that appear on the page, 6 of them actually are Nobel laureates. So that made it into its own annotation caption on the page right there. So that was satisfying. And then the last example I want to give is one that we ran in our July issue called The Whole Brilliant Enterprise. It is very beautiful in print, though it looks quite dark on the screens here. It ran across 2 consecutive spreads of the magazine, so that we got a lot of nice broad real estate for it. And the origin story on this is that in the course of reporting something else, I came across this fantastic trove that basically the NASA History Office every year publishes a summary of basically news pieces about aerospace. So U.S. accomplishments, but also, like back in the day, Soviet accomplishments and other countries as well, in this sort of comprehensive single report. And they've been doing it almost every year since the very inception of NASA. So I went to Jer Thorpe at the Office for Creative Research, and basically set his team loose on the project, and this is what they came up with. So what I loved about the chronologies was that you get like missions to the moon and like totally mundane budget negotiations all sort of mashed together on equal footing. But that property actually made it a really difficult data set to visualize. So they had to develop an algorithm where they basically took the stories and cross-referenced the data, the NASA database with actually the New York Times to look at where stories were placed within the paper, and then kind of used stories on page 1 are more newsworthy than stories on page 20. And so then they developed a newsworthiness ranking that they then took back to the original NASA database and pulled out common topics and themes and basically worked it all together to come up with this sort of stream graph word cloud mashup that we then ran in the magazine and was really successful. We had more than one engineer who had worked on some of those early space missions who were readers of the magazine wrote in to say how much they liked it. So that was very satisfying. So in the end, it's me at Popular Science doing data visualizations. And I get a lot of input from the art team and the edit team, so to make visualizations, I basically have to wear a lot of hats. I do a lot of data analysis. I do a lot of reporting. I do a lot of design. I do a lot of writing and editing. But the real way that I make data visualizations with a small staff at Popular Science is by collaborating. I collaborate with sources to help make sure that I'm using their data properly and that to help get things into the right format. I collaborate with studios that have the bandwidth to do a lot of original analysis, and I collaborate with everyone at Popular Science to make sure that the stories that I'm telling with the data are the right stories for our readers. So with all that collaboration, it's really not lonely at all. Thanks.